So basically, what's the difference between analytical queries versus like online transactions? Is that with analytical queries, you're trying to find the story in your data, whereas like traditional like OLTP databases, you just want to make sure that you capture this data, record it, and that's why you need to have all this classical, how it's called, the characteristics of atomacy, consistency, transaction isolation, and data durability for your database. For analytical queries, you already have a data, and you need to turn it into some form that would be queried, where you can discover different interesting stories, like what was the revenue from yesterday or something like that. So that's why like we do have quick diagram that explains 4 different kind of like surfaces where the analytics can be used. So there is a batch and a real time. There is the internal and external analytics, and I'll try to explain which ones. So when we're talking about this part with the internal and batch, it's your traditional reporting system. You have a very important person as the corner office, nice view, and this person needs to get the report of to run the business of the company, make some sort of decision. So traditionally running these reports, maybe even printing those reports, bringing to this person, and they need to make a decision about the business. Some sort of like dashboards that can be displayed, usually again printed, because you don't have with the tools that were available before, you will not be able to do anything with real time. So those dashboards can be updated manually somehow. With internal data that would be important for your business, but it's not going to be crucial for the business. For example, you're not selling anything, but this is important data to run your business, to know what's the health of the systems, how good systems are performing. So monitoring, observability, it goes into the world of real-time analytics, but it's internal, because you usually traditionally you're not exposing this for your customers, so your customers not paying money for this. And there's a new category that's called user-facing analytics. We're going to talk about this a little bit later, but this is going to be new category that we're going to talk. It's going to be external, meaning that your business will depend on this. Somehow you will be selling this data in some sort of form of maybe APIs or maybe actual user features that would be exposed into applications. I like to show an example of the user-facing analytics with I have this very cool combination of things called Whoop. I don't know if you heard about this. It's a combination of app, and it has a sensor, and the sensor constantly collecting data from my heart rate, and based on this data, they are building different dashboards that would be very much related to my data. So this is user-facing analytics, because I'm not entering this data manually. I'm not doing anything in order for this data to appear. It just appears here from the sensor. And I can get this information about sleep, and this data usually available immediately in a real time. If I would be training yesterday and today I need to make a decision, do I need to go hard on my training or I need to relax? So I can see my recovery is suffering because I was traveling, which is usually sleep deprivation involved here. And for example, like yesterday, there was like a very high strain on the training. Yesterday was a very tough workout. So those information collected somewhere in some form, but also gives me idea, like this is very analytical type of use cases, like how good or how consistent I am with my training. So that's example of user face, and I'm paying for those guys. I'm paying subscription for the given device for free, but I'm paying subscription for the data that they will be sharing. So That's the example of real-time external features that you're building and you're selling this. And there's also like external, any type of, you can do like reports from your mobile bank, or you can get a PDF that explains like what's happened with your bank account. You can see how much money you spent last month on groceries, travel, some other things. So usually this is kind of like, this is where this falls into these different categories. Now, talking about actual software that's used for implementing those things. Traditionally, data warehouses, there was the tooling that was used to build these internal batch systems. Data would be collected somehow, maybe files will be sent. This data would be loaded through some sort of ETL process, because you might need to turn this data and turn it into something that would be ingestible into the data warehouse in a format that data warehouse will be able to query this. Hadoop become another tool to perform this type of task for internal analytical workloads. Snowflake is the cloud-based solution that solves this, the people bringing data to Snowflake, Redshift in the cloud. And there are different tools that allows to perform so-called like federated type of queries, because usually people agree that SQL would be the right language to query this data. Hadoop tried to avoid this by introducing the Java API to writing the jobs, but how the Jeff Goldblum in the Jurassic Park likes to say, life finds the way. So people would find a way to use SQL. So that's why the introduction of tools like Pig was, I guess, the first implementation where you can use SQL for writing jobs in Hadoop and stuff like that. BigQuery is also another example from Google that allows you to perform this type of queries. In the world of internal and real-time analytics, it is a huge market for companies like Datadog. That's basically what they do, collecting the metrics, and based on these metrics, they're trying to learn some stories, how your system is performing, what's the vital characteristics of the systems that you use. There's also things like Prometheus. It's another popular database to collect time series data and query this into something that would be displayed on the Grafana. For external batching, you can do the same thing by introducing caching. So this data would be generated on these reports, and it will be available for delivery through, I don't know, like PDF that would be available through the CDN and stuff like that. Or there would be some sort of distributed cache in front of your API in order to deliver these results. And for external and real time, there's actually a bunch of different competing tools available. The Apache Druid, ClickHouse is very popular. Rockset is this cloud-based solution, and Apache Pinot. We're going to talk about Apache Pinot in this presentation. So that's the story. Do you have any like questions or concerns about the way how I structure the landscape of the analytics?
Maybe only comment from my side. You just asked if we, for example, are using something from this. I've noticed Presto, which is a core part of watsonx.data product of IBM. Yeah, so, and I assume soon you may have heard of this. Yeah, like it's a part of bigger, let's say, amount of products, like AI-based, like watsonx.data, and internally, I assume it uses Presto. So yeah.
So there's a cool thing about this. I believe there's no such thing as Presto anymore, because the Presto was named Trino. Presto it was called before certain release, and after that they now it's called Trino. It's open source version. It's essentially it is a engine that allows you to write a query against any type of database. That's what we call like federated query engine. You can have a multiple different connectors to Trino. They will appear as the tables, and you can do interesting things like join between your Oracle database and Apache Pinot. So Pinot has great integration with the Trino, and even cooler, the Trino supported joins and the Pinot supported joins. Before it was natively supported inside actual Pinot, we were recommending people to use it inside Trino.
So Trino, it's like a new version of Presto.
Yeah, it's just like a next version. If you Google, you will understand that they're saying that since version 43 something, now we call it Trino. I guess it was before because of some sort of like a naming and the copyrights and stuff. So Presto was initially created in Facebook, and after that it was open source. Founders they tried to work on this one. They started either foundation or something like that. They donated to some other foundation. Now there's also open source version, and there is a company behind this called Starburst. They provide the support and development, but there's a lot of like open source stuff where the Trino is used.
Yeah, and besides that, this internal real-time, so it can be used for example, IoT devices. Here, maybe you have heard or not this unified namespace approach when, let's say, number of different, I don't know, tenants from different OT operation technology from, let's say, plants works, like capturing data in real time, and then there is aggregation. Central, decentralized couple of brokers of MQTT, and let's say we are working, for example, with these MQTT brokers to extract some kind of analytics, like using NiFi.
But those brokers, they usually don't have the storage itself, right? So
yes, so
you need to use some sort of
like Kafka, for example, yes, so like capturing the real-time data into MQTT, then putting it into Kafka, for example, for persistence. Things like this. Yeah. So,
yeah. So I would say this actually might fall into kind of like a external use case, because at the end of the day, you want to get some sort of insights from this data that you collected from devices and somehow deliver this to end users. So it may be not, if whenever you're charging money for something and it is core of your business, so it's external.
Okay.
Whenever you do this only for understanding how good a thing is working, for example, you do the Uber, for example, right? So they can have a multiple different telemetry data from cars, from different the point of sales, if we're talking about the Uber restaurant business and Uber Eats and things like that. Actually don't know if it's do you have like something like.
But while you are mixing actually internal and external, it's quite subjective, because most of technologies can be used also for both internal and external. I understand your points of presentation here, but considering the technology stack, almost everything can be put in internal.
That's correct. Yes. From the technology perspective, pretty much anything can be used for any type of use case. I'm trying to kind of like make a point about where different tools would be better to use for which use case. All right. So how many of you use LinkedIn here? Everyone. Okay. I'm pretty sure that the answer to this question like 5 years ago. Oh, okay. Let me ask you a different one. So how many of you use LinkedIn today? Okay. So which is good, and it's always proves my point. Like the answer to this question would be different if I asked you like 5 years ago, because 5 years ago it was kind of okay. I have my resume in LinkedIn, and whenever I feel need to change the job, I need to go there and change my resume. So the people who build the LinkedIn, they was like, okay, so how we can change the situation to become a actual social media platform or platform where the people can go and communicate from the point where we will glorify the resume database. So they start thinking about improving engagements, and everything that happens in LinkedIn, everything you do there, if you go and visit other profiles, you're updating your profiles, you liking someone else post about something, everything generates an event. And those events will be stored inside one big Kafka cluster that they have. Kafka also was the system that was designed to capture all these events in a massive scale. And so they're thinking, okay, we have all this data. So we have all this data. Now we need to do something with this data to increase engagement of people using our platform. So they dumped this data the first time into Elasticsearch and they tried to build something that would, at the end of the day, become things what called who viewed my profile. And they tried to build this using the Elasticsearch. So what's this feature? So this feature gives you idea who viewed your profile. Because they know what other people are doing on the platform, they will be able to correlate the data that would be relevant for you. And this is actually, apart from being cool to know like who view your profile, how many of you actually Google yourself? I do this all the time. So that's fine, no shame on it. So that's the same thing, like from the perspective of how it's called, vanity. It's okay, but also, like I was asking a friend of mine about this, and he's like, I use this when I go into interview all the time. And more importantly, I'm interested if someone from the company where I'm interviewed for looked at my profile within, I don't know, hours or maybe days from the interview. So it is real time to care about the data that happened like immediately after interview, so he can feel good about themselves because someone checked their profile. Maybe someone would be the next stage of this interview process. So, and by design, this is very good example of analytical query, but they have a massive amount of data that come into the system. They need to solve the situation how we can read fast from this massive amount of data and deliver this with very low latency, because you don't want to sit there and wait when this report will be generated or sent to you at the end of the day. And also, LinkedIn has the hundreds of thousands of users who wants to use this feature, or at least they can use this feature. So there's a few interesting characteristics of the system that should support this type of use case. It's the freshness of the data. So we want to get, we don't really care about who viewed our profile a month ago, because things might change like significantly. We want to have very low latency. We want to get this nice graphs that will be, if we're changing different dimensions, we want to see different companies, we want to see who from the company, maybe it's from the C-level, or maybe some individual contributors want to see different dates. We want to see some nice graphs, and they need to change super fast, because why not? Like I showed the example of my system. I can go and see different different timelines of my my fitness data so far. So also massive scale, massive concurrence. So another use case out of the same data, because they know who posts something from your network, they know who updated their profile, they know who write the post. How about we use the same technology and the same stack to build this personalized newsfeed? So every time when you open your LinkedIn page, you see feed from your friends, colleagues, and so far and so on. You can see who likes someone, who writes something, who reposted something, and stuff like that. So this is sort of like the SQL emulation of the SQL that will do this type of use case. So, and this SQL is also very analytical by nature, because we're using the function to do like summing of the elements of this newsfeed. We can use different ranges from various data points. We also can have different ranges based on the time. And also same characteristics. You want to see fresh news. You don't want to see like old news. Fresh news is always great. Number of users, very, very big number. and the number of how fast this needs to be executed also here. Another example, we have Uber that not only performs the ride sharing, but also they have another side business that allows to connect the people who are hungry to people who can make this food. So they have this Uber Eats business, but also for restaurants, they're providing this type of dashboard where they're showing how good they're performing on their Uber platform. So because they need to justify the business for restaurant owners if they want to join this, they build this this dashboard, and this dashboard actually good example of user-facing analytics. In this case, restaurant manager is the user, not direct the customer is user, but rather the restaurant manager. All right. So and the common thing in this. All these the use cases use Apache Pinot. Apache Pinot was developed in LinkedIn to solve this particular problem where their Elasticsearch will not be able to do this analytical queries. So Apache Pinot, it is distributed OLAP database. It is analytical database that can perform queries with very low latency, with high concurrency, and very fresh data. So that's kind of like a three things. Yes.
Maybe a bit dumb question, but
Dumb questions only
Okay.
people. Anyway,
sure. KSQL.
Yes.
How it is compared? Like, may I ask you to
Yeah.
elaborate a bit into this?
yeah. I can talk about this when we're going to talk about Flink a little bit. But essentially, there's a product called KSQL which is marketed as a streaming database, and actually I have a talk about this on Wednesday. I have a talk in the J Prime conference where we'll be talking. The KSQL is not it's a streaming database. You can query stream, but you will be struggling to performing some sort of like analytical queries. So you can think about this. What's the streaming database? In my understanding, the way how I like to talk about this to people, it's streaming database. It's basically two things. It is some sort of like a query engine and your storage. So in this case, Kafka is storage, and your streaming engine would be the KSQL DB thing. And whenever you don't have a storage, for example, Flink is not streaming database. Flink is only stream processor because it doesn't have a storage. It has a storage for its own internal things, but it is not the kind of like streaming database per se. With KSQL you can have some sort of like persistent queries that will be constantly running somewhere, but KSQL doesn't have characteristics of your traditional database. You can do indexes there. So,
My point is that you have different reasons to use, of course, Kafka and KSQL and that's the exact reason to have actually services with storage and without storage. But you will explain this, so sorry for interruption.
No, it's okay. No, I'm open to have a conversation.
Different cases, and it is not just a mistake that
you're talking 100% like a consultant. Like when I was in professional services, my default answer was it depends. And we will need to kind of like break down a particular use case and see which tool would be better for solving particular task. And the answer is always it depends. Depends what you're trying to do. And every time you're trying to generalize some sort of the problem, you'll get some sort of like generic solution that would be good enough for solving those. But if you need to go into more details, so KSQL works great when you need to do kind of like a data transformation. That's your streaming kind of like ETL type of use case. To be determined, it still will be determined if the performance characteristics are there, because the KSQL depends on the Kafka Streams technology, and Kafka Streams technology has certain limitations It's very tightly coupled with Kafka. Obviously, it's called Kafka streams. For example, Flink, it's not tightly coupled to Kafka. Kafka is just one of the sources or one of the destinations. With KSQLDB, there's a lot of like you narrowing down.
So for particular cases.
Exactly. Yes.
Okay, but as for Pinot, so how it is different from Flink and KSQL?
Yeah. I will be showing some of the demo use cases, and you will be better understand when I will be talking. I probably will just like switch to demo. It will be much more interesting. I just wanted to point out one of the things that I want you to remember is like this thing. This probably would be the most important slide, and you get back home and your certificate author will ask you, okay, so what's you learned today? And said, oh yes, I know what's the real-time analytics systems now. And you can share this numbers. But well, the Apache Pinot, it is system that you can put as a last mile of delivery of the data. So you can put the Pinot behind some sort of like API layer that will be delivering actual data to users through mobile, through web, through any type of applications. And you will be able to do this type of use cases using Pinot. KSQLDB, you will not be able to expose for application developer. You will be mostly using this as a layer of processing this data, kind of some sort of like a materialized, and same with Flink.
So can we, let's say, name Pinot as some kind of cache? Something.
No, technically it's not a cache. So it's a database. It's exactly like back in the day when we're developing this 3-tier application. You have database, you have some sort of like a business logic, and you have a front end, right? This database, usually in the past, we used any type of same database that we use for writing transactions. We use this for querying transactions. We did joins, we did aggregations, we did sums, all sorts of things. With the scale and the number of data, amount of data and use cases that we are implementing, that's why it's distributed. So that's important component. It's distributed system. So it is designed to be scaled to support multiple use cases. It is heavily read-only system. So data will arrive there, multiple different sources. And you will be using Pinot to build your application, to build your dashboards, to build your the mobile applications with nice graphs.
Do you mean you're exposing semantic models here?
Not necessarily. So your semantic model, it's your API layer. Like whatever you want to do, your API layer, this is how you're going to be talking to front end. You don't have to expose, because with there will be use case where I'll show you where you go between 2 tables and join in a query, or you opt out for something like one big table that includes multiple dimensions, like hundreds of dimensions, and you will be using this as a query, this one big table with one simple selects whatever from fields. Yes.
Is it a relational database?
Is it relational database? It uses SQL as a query language to get this data. You will be able to perform joins, but there are no constraints about prime, the prime keys, foreign keys, all these kind of things. So there's some characteristics of relational database, but and also SQL can be a subset of SQL that only perform queries like select, or you can do select from select. You don't have inserts. You don't have update type of queries. The data will be arriving into Pinot through ingestion mechanism, either batch or streaming ingestion.
Into what happens if I found that there is a mistake in my data and I have to modify it?
Yeah, we do support something called upserts. And upserts, it is the way how data in Pinot is immutable. So you will not be able to modify, but you will issue another event that will include updated data. And Pinot will understand that, okay, so I need to use new data instead, but you will not be rewriting your old data. So all these things were, it's kind of like when I start, like maybe like 10 years ago, when I moved from consultancy into the data world, I started with a company that were building distributed caching system. And the query logic was easy. It's just like key value store. If you know the key, you will get the answer, the result. And for me, it was very uncomfortable because I was taught throughout my career, like in university, and after that, building subsystems for banking systems, that when you design your database needs to be in a third normal form. The duplication of data is bad. You can put your entities in the different tables, and after that, you're doing the joins. It's good. The good thing when you put this on math, talking about relational math and all this kind of stuff. In the real life, it's not that good, because usually everyone will tell you that if you have a massive amount of data, joins will always create the problems, and you will be suffering with performance. You need to have skills to tune the indexes, understand like how properly you query, and things getting into another dimensions when we start talking about the sharding of the data and making this data distributed across multiple nodes. You need to separate writes from reads, and all these things kind of like definitely can overwhelm everybody. Huh?
You're at Pinot.
No, it was like my road was very long and bumpy. I never.
Like architecture, because you're describing the evolution from this to normal form, the place where you read and you ingest and you don't have the normal form.
Yeah. Like Mikhail said, it's like about the use case you're trying to solve. In some cases, I was able, when I was doing the Hazelcast back in the day, we were focusing on implementing systems where your default mode of querying the data is key value, and if you know the key somehow, the retrieval time would be extremely fast, because it's usually constant time, because you know the key. Based on the key, apply hash functions. Result of this hash function usually constant, because it will give you a number, and you know exactly where the data will be. When you start talking about some arbitrary stuff, you want to know that particular field inside this object that stores in your cache needs to be queried. There would be like implications like, in order to find this, since it's a Java and everything stores inside the object, you need to deserialize it. It takes time. You can find a way how you can optimize it. We come up with a very smart deserialization mechanism that doesn't require you to fully deserialize object. And you're going into a different route, because like all you want to do is to write the query to get the data. And now you need to go in the weeds of understanding how Java the object serialization deserialization works. It was like madness for convincing people who came from the DBA world to use something like hash. Developers, whatever, key value. We know hash map. It's the most famous data structure that everyone knows, because everyone asking this on any interviews. Probably like hash map and maybe B-trees. I don't know. So yeah, the going into the route where, like, okay, we don't need to have third normal form, and it's okay where we can sacrifice storage for speed of querying. But again, that time I didn't know that even storage was not a problem, because there's a ways how to optimize it. Instead of storing one record, we can store dictionary and storing only pointer. So yes, we kind of have a duplication, but in general, it's not going to be duplication. It's going to be internal data structure that will be having the pointer from, instead of having storing the actual field, we're going to be storing the pointer.
Index pointers.
In indexes, yes, of course, yeah, and how to access data faster through indexes. Let me actually let's yeah, since we're talking about like, and I don't want to do like hand waving and stuff. Let's talk about how it looks like. So again, let me bring this real quick to show you. This is the repository that I was talking about. So everything that I will be showing is here, and it was transformed from the workshop. So you can find there's a lot of explanations and a lot of should be something. Yeah, the first use case is that we do have files that will include data about movies. I like to talk about movies because I like watching movies and I know something about movies. I love the business of movies. I like how the movies are done, actors, directors, screenwriters. So bear with me. There will be some references. So I have information about movies. This is the file, JSON file. It looks like this. Let me do this one. Let me do bigger screen. So the data looks like this. So it is JSON file that will include information about title, release year, country, actors, and this file will include just the JSON records. So that's the typical situation. You have a CSV file, you have a JSON file. Now you want to do some sort of queries against this one. So one of the things that we do this in Pinot is that we have a job that will ingest data inside the Pinot. And this job would look like this. We can say that each individual line of this file is what we call JSON record reader. In this case, it's not technically JSON object because it's just each individual line will be JSON object. And what it will do, just reading the folder where all this data are available, reading files, and after that, uploading this into Pinot. And inside the Pinot, it would look something like this. So the Apache Pinot comes with the visual kind of like UI thing that first of all allows us to see what is going on in our cluster. As I already mentioned, the Apache Pinot is a distributed system, includes multiple components. It includes component that would be responsible for storage. Inside the Pinot, everything will be stored inside the segments. Those segments are unit of storage. Your data will be stored there. And I think it's a very smart name to call the component that will be responsible for storage as a server. So in this example, I have just one server, but you can scale this independently from other components. So server stores data, and we have a broker. Broker will be receiving queries from applications for different clients, from different other systems. So by separating brokers and servers, we separating storage and compute. When we feel that our latency is suffering, we might, because of the number of clients, number of users, we can scale brokers without scaling our storage, and vice versa. We can say that, okay, looks like with the data is growing very fast, we can add more servers, we can store more data, and our query layer still will hold. So those components can be scaled independently. Comparing to traditional databases, like we're talking about your MySQL, your Postgres, storage and compute, they are tied together.
One question.
Yes.
Are servers the storage of the data? Do they duplicate the data, or is the data sharded, or how is?
Excellent. So inside the server, so inside the server, those squares, the dark colorful squares are segments where your data is actually stored. You can have this specified replication factor in case of you want to have data stored not in one place. Maybe you want to make sure that there will be outages and you will not lose your data. So as you can see, there's a segment 1 on server 1 and server 2, segment 2, for example, on the server 3 and server 2, and the broker from the metadata actually can balance the load from which segments to read. Sometimes some segments that we're reading from, they might be stored on one server, so you don't need to go to another server to query this data. As you can see here, we can have segment 8 available on server 1, and my thing important. So again,
Like optimizing lookup.
yes, you can. It's based on the metadata that stores inside the third component that I will talk about in a second. But if I have server 3 has actually segments 2 and segment 8, so the query can be just executed on the server 3 and return a result from the server 3. Inside the segment, do I have it here? Inside the segment, the way how the data is stored is actually what we call in columnar format. So remember, like in the database, when you do insert into and you specify the columns, and after that you specify values, you care about inserting one particular record. With the Pinot, when we do this ingestion, during the ingestion process, we actually, because we know the column names, because we specify this in the schema, we turn this into the format that would be optimized for storing this data and optimized for querying this data. So we make this data.
You have something like Cassandra format?
Yeah, the Cassandra supports this columnar format, and the Pinot also have like a very similar to Cassandra. So as you can see here, our like IP address, user ID, remote user time, request status, blah blah, all these things will now will be stored inside segments. All IP addresses will be stored in the segment. All user IDs will be stored inside the segment. Some of the indexes also will be stored inside the segment, so they will be closer to the data. So let's drill down into IP address. The way how it's stored. We can have like thousands of the click streams, the events from this, and it might include thousands of different IP addresses. So every IP address will be stored inside the segment in a format like this. Come on. Oh, yeah, something like this. So inside every segment, we will have all IP addresses. So if I would say, this is my schema for my movies, I will have a column that segment that will include movie ID information, and there will be 1, 2, 3, 4, 5, 6, 7 inside the movie ID. Every title will go under this title. So instead of care about the records, we start care about actual columns. And the columns can be dimensions and metrics. So some of the data that we'll be performing, and obviously the dimensions that we'll be using to slice and dice our data. This is where I specify in the configuration. This is where I specify replication factor in case I want to spread this data. But in this case, replication factor 1, because I have only one server in my configuration. Inside this Docker file, you will find all these components. There's a control. That's the broker, server, and controller. So controller is the third component that will be performing some of the housekeeping stuff inside the cluster, making sure that segments are online, metadata is updated, so the broker knows where segments will be, where to send the query and stuff like that. And also, Pinot uses Zookeeper to store all this metadata. Kind of like it's a distributed database that uses another distributed database to store some of the data. Yeah, we created this cursed world ourselves. So yeah, there's a Zookeeper will be used for storing some of the metadata that controller will be using. Every time when we hitting the broker will consult with controller what's the topology, how the segments are distributed, and after that issue the query to particular segment. From perspective of user, it's just the tables. So in this case, there's a table called movies, and I can run the queries like select count, and get me 900 movies. And also with the response, we'll always get information, some of the stats in this particular case, because there was no indexes involved, full scan, full table scan. It took 3 milliseconds. It's relatively small query and small data set. There's nothing impressive here. You can do something like select. So if I want to run the query that shows the most popular movies in the 2014 based on the genre, I can run this query and can see that's your typical analytical query that will run. Again, by default, there's no indexes to turn on. Only it is what it is. So. So there's only inverse. I forgot which one. So basically, like every time when we see, so let's take a look at the data. I don't know how. Let me show you. Let's do one more time. So if I were to select star, so this is how data would look like. So what it will do, it might take some of the metrics fields and will create the indexes for those fields, but you need to manually tell to create these indexes when you create in the configuration, or when you update in configuration, indexes will be created. There's tons of different indexes.
Similar to indexes. So
speaking about this one, we're actually using Lucene for some of the full text indexes. We use a JSON string, a JSON path type of indexes for JSON rollout. There's tons of the different indexes, and the cool thing about this is also pluggable. Every new release, we add a new type of indexes. Like right now, the team is working to optimize storing the strings there and automatically extract some of the repetitive data from string. Imagine you have a logs, and there might be some of the kind of things that repetitive with text. They will be able to extract these placeholders as indexes, hopefully. And let me show you. If we can do.
kind of index run left.
There's a ton of different things that you can apply for.
Connected optimization of Viktor that you mentioned.
Yes.
It's not a problem when you discover there are.
Yeah. So those the index for particular fields, they will be stored in the same for the particular column. Sorry, it will be stored inside the segment as well. So you will be able to do this. Yeah, it will be. There's like a bunch of different ones. So now let's go with the another use case. let me kill this one. So now let's go with another use case. This use case will use, this is simple, like everyone can do this. We have a tons of files, we upload these files, create these files, build the index, it's super cool. Now, the interesting part is happening when we need to bring some real-time data. So the Pinot has native support for systems like Kafka, Kinesis, Pulsar, something else. So essentially, you can plug any system, create this what we call the real-time table. By the way, these tables that we use, table names for batch ingestion, we call offline, but it's terrible choice of naming because it's terrible. Because people thinking that offline, what does it mean? It's not actually available for query or whatnot. No, it's just that the way how the batch ingestion thing works. Those segments created outside of Pinot cluster by separate job. So we're reading file, parsing this file, creating these segments, and when we're done with this batch job, we can tell Pinot, hey, there's a bunch of segments that you need to turn into tables, and Pinot just picks them up and make them available. With real-time ingestion, this segment will include the Kafka. How about Kafka? Like how good we know Kafka or it requires some refresher? Producer, consumer, we understand. Okay. So essentially inside each segment that will be reading data from Kafka would be its own Kafka consumer that will reading particular partition. So that's why it will match number of segments in the real-time table with number of partitions inside Kafka topic. So what next use case will show? So if I go to 02, introducing two more components here. Actually, 3. I do have Kafka that runs in without Zookeeper, so only Kafka. I do have just for visualization purposes, Red Panda console, which is UI free UI for Kafka, and also I have let me run this while we're starting, and I have a producer. So I will simulate a situation where I have a system that will be constantly generating ratings for data. So I want to do information from the music or movies and the ratings of these movies. And after that, I want to join this data from batch data that I have in my files and the data that in real time comes through the Kafka. So that's what I'm trying to do right now. So while it's starting, usual question when people asking how fast the data will be available inside the Pinot to query when it will be produced inside the Kafka, and the answer is immediately. As soon as it will be consumed from Kafka topic, it is available for query. You don't need to do anything with like reprocessing this data. You don't need to do anything with to make it. It's just like also if you have indexes created on those tables, the indexes will be created as well. So correct. So I have a topic that would look something like this. For it's just a real situation where the people click in the website and voting for different movies. Movie ID, a rating, and some sort of like a timestamp for this. And those are see it's loading should load like 1 million messages. Now, so if I go to Pinot, I'll see this ratings table, and it immediately number of docs would be corresponding to number of messages in Kafka topic. That's a 329. And if I'll just do a query, it's like things are happening in real time. So like I refresh it here, 307, 390. So it is immediately available for query. So the information about the ratings landed here. So with this, I want to do something like, where's my cheat sheet? So I can do stuff like this. I can go and join these two things. I'll take the ratings from movies. The movies also include some initial rating information. I get the title, and I also can get the rating from the rating table. And this data will be constantly updated. So it's error because join requires new version of the query engine. I just need to put this check mark here. By default, in future release, this will be default thing. Now, so it says 500,000 documents scanned within 800 milliseconds. Even though it's local, blah, 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 it's still a lot. So 800 milliseconds, if I run this one more time with the beauty of just-in-time compilation in Java, we reduce this number even lower. So it is fast, even for local setup, and with some of the data that not super exciting, it's still fast. And I'm getting the rated data. I'm not using any smart algorithms, so that's why it's very quickly saturated around the 10. When I generating those ratings, they're not even normal distribution. They just like, you know, whatever default random in Python is available. That's what it does. So this is number of documents inside database was loaded from Kafka, and this is number of documents were scanned, and this is time, and we get the bunch of interesting things here. Now, questions? Yeah, again, we do have a files that loaded from the Flink table. Whenever new ratings will arrive in the Kafka topic, this data will immediately land Pinot, and you will be able to query. Let's see if I go here. 1 million messages was loaded, and it should be, oh, where is it? Yeah, 1 million messages here, also here. If I want to do just like select, if I do select count, kind of your the brute force query. Number of documents scanned, 1 million queries. It's the reason why it happens so fast because of the structure. Because like if I need to just count on this, I can get one segment. I don't need to go anywhere else. And inside the segment, I can just this count super quick.
Segments of segments.
Yes. Yes. So the aggregation happens on the different nodes, and the broker just like join the data when the server already sent back result.
So it's pretty good to have this.
You don't have to do this locality; it will be done automatically. And especially if you have indexes enabled inside in different tables, the indexes would be local to data. So when we query, it still will go into the same segment. Query will be used to locate this data for using indexes, and data will be retrieved because they are next to each other. So now the people ask, okay, if the Pinot can do everything itself, like why we need to use Flink for this? Like why bring in the third component? So what is Flink here? So Flink, it is it's a framework for building stateful stream processing systems. Regardless if its data comes from streaming source or it comes from batch source. And the Flink doesn't have any dependency on Kafka. It's one of the components that can be used. Flink is a general purpose processing framework. Another thing that Flink does, it's unifies notion of streaming and batching. And basically batching, it's one of the corner cases of stream. It's a stream that just ends. So that's why it says like it can be computation on top of unbounded and bounded data. Bounded data, your files, unbounded, your streaming system. So the Flink traditionally, it's a third system. You need to run another cluster because Flink, you're submitting jobs that will be executed in the cluster. Traditionally, Flink was using the Java or Scala to write those jobs. But in the recent years, there was a lot of attention around Flink SQL. So Flink SQL, it would be very close to what KSQLDB does. It takes the SQL and turn it into actual job that would be executed. With KSQLDB, you take a SQL and turn it into Kafka Streams topology. And in the Flink SQL, you take SQL and turn it into Flink job. Why we need this? There's a bunch of use cases where Flink SQL can be used. One of the examples, the reason why I built this workshop around not talking any coding, so that people don't need to compile and to mess around with different dependencies and things like that. So we kind of sort of staying in this gray area, like everything is SQL. But we know that this is not entirely true because SQL means different things for different systems. So both Pinot and Flink, they use same framework for dealing with SQL. We use Apache call site, which is open source framework for building systems, for parsing SQL to understanding query plan and integrating with your application. KSQLDB doesn't use Apache call site. KSQLDB uses the Antler as a grammar parser. There's its own parser. So that's why like a Pinot and Flink, they're closer to ANSI SQL, to standard SQL, where with KSQLDB, they can have their own, there's like create stream type of kind of use cases here, there. Now, why? And the question here is obviously not that obvious because okay, so it's another system that does SQL. You can do joins there. You can do why you need to have a Flink. And the answer is latency. There's a situation. So remember when I was talking about different tables and talking about the joins, where those joins like relatively, this is the relatively not complex join, especially if the join happens by movie ID, it's relatively okay-ish. There's a situation where you might want to have joins with multiple different tables. It doesn't support in Pinot. At least I believe not supported right now. And this is where we're again getting back into situation, one big table versus the multiple different tables, and after that we're doing joins. Another use case where Pinot cannot do because Pinot doesn't have a concept of materialized view. So sometimes, and many use cases, you want to have something that would be, constant update. The KSQLDB has a concept of materialized view. And with combination of Flink plus Pinot, we can kind of emulate this. So what we're going to be using Flink for? We will use Flink to do pre-join before data land into Kafka. We can do join in the Flink, send this into Kafka, and after that we'll use one big table rated movies from Kafka and send it.
Kind of slightly different concept because it seems that actually Flink is kind of ETL for streaming tool. Materialized views are used mostly for performance purposes, and I don't know, but maybe sooner or later you will have Pinot. I mean, it will not replace material views.
Yeah. So we don't have any like a. I cannot create a table from result of this join. So that's what limitation that we have right now, because we require. There's no concept of create table inside Pinot. So the way how this particular solution would look like, we will do everything what we need to do in order to, like you said, like to do our. It's more like a T from ETL, right? So it's we only do transformation. We do the table to string join. We do have data that will land inside these two topics. So I opt out of having my movies in files now, even though Flink can easily read the files. I don't need to use a Kafka for this, but you know, after years building solutions on top of Kafka, everything looks like a nail, and you know, like I need to send everything through Kafka. I'll do the table string join, save data inside these rated movies, and after that, I'll already create the real-time ingestion table where we'll have one big table with all things. So let me kill it. And all these three use cases, they are self-contained. They are not interfering with each other. So you can play around and see with different technologies.
One question, please.
Yes.
In this solution, we had batch-based. We did not have streaming of the ratings, right?
No, the streaming actually went through Kafka. We have a producer that generate ratings. Those ratings will land in Kafka topic. Based on this Kafka topic, we created a real-time table configuration inside the Pinot. And from the first example, we kept our movies from file in the batch in this case. So we have ratings information come from a real-time table in Kafka, and movies data comes from files is the batch.
Right. And we don't, if there is an update in the ratings, we don't have streaming of this update outside. So if
no, it will be if we have update on this rating, we have an update inside. It's done through Observe. If there would be
no, I mean some client which is reading the ratings, will he get the update with via streaming or?
It depends what you want. If you want to, there's no
Is there a WebSocket or how the client can connect to the Pinot and get the streaming?
So the way how you connect to Pinot is how you connect to your traditional database. There's a driver for Java. There's a JDBC driver and the Java API. There's a Python driver called PinotDB, and I believe there's a.
So if I want to have a streaming, I need a streaming driver for the database.
So if you want to have a streaming, there's no concept of like a streaming SQL in Pinot, because you're executing query,
Right.
and it will be executed on top of data.
Right.
So you execute the query, you get the result set with all your data. When you call this next time, you will get updated data because your ratings table is updated. So you can implement this through kind of like a pooling of the data every second, and it's quite all right to do in Pinot. Again, remember the times where we were told that do not, the call the database without like connection pools and things like that. So driver already handles this pipelining of the queries and things like that. And in Pinot, it's quite all right to, just call it multiple times query and get the data back.
We have supported eventing abstraction. That means if something happened to be possible to have HTTP call to another.
Not inside the Pinot, because it would be your traditional request response. There's no kind of like, and I see you when you need to.
Other systems, some other systems support this kind of
Yeah.
pattern.
I think what you will be end up doing is that on your application level will be just like pulling the queries from the Pinot and refresh like front end or things like that.
Yeah, it is possible. Just I'm asking if
Yeah.
it is support.
No, not I'm aware of. Yeah, that might be potentially some of the improvements that engineering would look into to implement. But this is not something that it's kind of like the first thing that you're going to do. Like one of the immediate thing that will probably happen this year, it is the wire compatibility with Postgres. So you will be able to use same tools that you use with Postgres. Obviously, it's not going to be a query compatibility layer, but at least you will be able to connect like things like a Tableau or any type of like UI tools. You still need to be kind of issue the Pinot dialect of SQL, but the wire protocol would be compatible with Postgres. While I was talking, I should have run this thing. Okay. The building another thing. So we're adding a little bit more components here into this inside here, Docker Compose. Same producer, we still continue generating ratings. Pinot Zookeeper, Pinot Controller, Pinot Broker, Pinot Server, Kafka, and the console. And also, we're going to be using this Flink components, SQL client that will be interacting with Flink cluster, job manager and task manager. That's components of Flink. And I have an example of superset, but I haven't finished it yet. Actually, this probably would be the most full example of the thing. So in this case, I also wanted to show the Apache superset, which is open source, the dashboarding tool. And Apache superset has built-in support for Pinot. And we can go and explore, see what kind of tables, and after that, just like throw the dashboard. Point of this to demonstrate that the Pinot is your last step before you actually will be showing something to users. Whole point of Pinot is bring it closer to your application layer that you will be building an application on top of. And the data can arrive whatever through Kafka, through files, through Kinesis, and so forth and so on. All right, so let's see what do we have here. So we have a Pinot. Yeah, so the Pinot, in this case, there's one table, rated movies, that is empty. So this table will be connected to topic called rated movies, which is also empty right now. See, there's nothing here. We do have a table topic that has movie data. So all our movies here. Instead of having this inside the file, we have it now in Kafka. Also, we do have a Flink here. So Flink has a console that shows what kind of jobs here. So we don't have any jobs running. Everything is clean. And yeah, we'll see about superset if it works. Now, I need my cheat sheet. Where's my cheat sheet? So I'm going here into running my SQL client. So now, what I want to do, I want to start a Flink job that will take movie topic, take ratings topic, do the join, send data back to Kafka, and after that, Pinot will have one big table of rating points. So I'm creating a table inside Flink. It's called create movies that will get information. So it basically will read data from Kafka topic, parses it, and we'll store this inside Flink. So I can do something like select.
Third component of file versions.
Let's not first. Like I'm trying to. So
take it back. It will
yeah.
be fresh for display superset.
Can you say again?
Get computed, get it back, and you will have it immediately for display to the Pinot.
Yeah. So, for example, now I created a table from movies inside of Flink, so I will be able to do stuff. Where's the table? What's the table name? Movies. Let's Pro. One title. Technically, there's 4 movies of a lethal weapon, but I only have 2 movies in my database, so it's technically correct. So we do have a stream processor that's running, and if I go here, I'll see there's a bunch of completed jobs. So every time when I run the query, that will create small job inside the Flink. It will be executed, and I can see what kind of tables will be affected with this one. So we do have movies. Now, next step, I need to bring the same stuff for the ratings. So there's a movie ratings table. Movie ratings. Also from here, also we were saying like read the topic from the very beginning. So we're saying the latest offset. And where's the yeah, let's see if the ratings actually works. And since data flowing, we start doing from the beginning in data flowing. It's kind of like a constantly reevaluating this data. And it's also will create, there's one job is running. So because it is constantly right now updating my screen, this job is in a sense of running the segregation on this UI. When I stop this should go away. Yes, it's gone. Now I creating a sink. Now I'm creating another table where result of the join will end up. So in this case, I'm using this connector called Absurd Kafka. So in this case, if this sink, everything that we will be writing into this table will be written back to Kafka. And every time, so this is join what I try to optimize. Let me show you first join before, so it works. And the rating is constantly updating right now because this is a running join. So now, because this job is only running while this the screen is open, I wanted this to persist. And where I need to persist, I will persist it into the sink that we created the one step before. So in this case, I need to add insert into. And what we will see, because it will be running in the background, we don't don't see anything here. What we will see here immediately inside the rated movies, we'll see the data that will include information about movie, and we'll have a new updated rating. And also, this information will land immediately into Pinot. So, in order to query rated movie information, I don't need to do anything else because everything would be available as is. So rating will be updated if I will run this. We have a recalculated. Probably UI doesn't. Why would I see it? Recalculated rating. It should be. Or maybe it's just the way how it displays it. Yeah, it recalculates because eventually it was reach out the rating 10. One more time. So the real-time ratings arrive through the real-time the topic. Movies as a table appeared inside the topic. Flink will read ratings in movies, does join, and sinks it back into rated movies. And we don't need to do any joins on the Pinot side of things. We have one big table with all the data. We have a bunch of 1, 2, 3, 4, 5, 6, 7 different dimensions for some of them dimensions, some of them the year. It's the dimension actor as a metric. Let's see if I will be able to show you a superset. And thing is with the SQL, if I will kill the console, it will stop the job, obviously. So not sure it was obvious, but it was obvious for me. Let's see. Where's it? Okay.
But probably you have different mods for these jobs. Now you run it like in the application, but you can run it in Python.
Yeah. So in this particular case, I don't touch anything with actual like production deployment of these things because it's more like a developer like approach. Obviously, you will be running a cluster that will be responsible. You need to properly size it so you will be achieve the level of latency that we're trying to achieve here. Let me see if I have superset set up. Let's see. Create configuration for superset. Something. So this is the this is a very cool tool. I highly recommend if you do anything with data and you really don't in the mood of building some sort of like application to quickly display this, just play around with the superset. Now we're going into settings, add database connection. We can say database. We can say here Pinot. Apache Pinot is supported here. I'll have Pinot. My URL. So this is the URL that will connect to broker, and also I need to specify where the controller, since they're running inside one Docker container. I can address this by container name. So we can do this connection. Connection looks good. I can connect to this database, and now there's also SQL console available inside the superset, and you can see the rated movies. And can explore this. It shows me what's the schema, how the schema looks like, and you can do query some sort of like. This is my favorite. Oh. In a stable with. because everything, all the rated stuff, is tiny. So because this table now includes all information about all the past ratings, there's no kind of like I need to do some sort of find what was the latest rated time and maybe sort by this and get the result. But for every title ratings. Yeah, so in this case, something like another thing that what you can do to create data set from this one, say that we're going to do Pinot, the separated movies, create data set and create a chart. Now, what kind of chart we can create here? See if we can do bars. Do bars. So we're gonna do for metric, we're gonna do rating, and let's do average, and we're gonna do time. The wrong type of chart. So it's average rating, but X should be different one. It should be probably something else. Anyhow, so yeah, the idea is that kind of like build some of the because now for each movie, my data is now screwed because of the, again, not super good algorithm of generating ratings. So for each movie that I have here on my x-axis, I have a, let's do pivot. Instead of this, what's gonna happen? I have another foods. Movies. We'll go something like very simple. Tables, average rating. Yeah, something like this. Yeah, this will do. Like for movie, we have average rating. I'll do a chart. Cool. I can build dashboard. Rating. And let's do. I have a dashboard. I don't have a dashboard. I need the dashboard first. Dashboard. Dashboard. Okay. Now I can save this. Dashboard. Save and go to dashboard. Why it is not showing images? Just showed me it better. This one should work, right? So it should work. Dimensions. Here we go. Yeah, something like this. So the picture. Yeah, something like this. And you can do stuff like this one, make it look bigger. Save. And this data can be updated in real time. You can set auto refresh interval every 10 seconds. So, and this is how you have a real-time data comes through Kafka, processes through the Flink, push data into Pinot, and use something like superset to build the dashboard. So super quickly, even like dumb person like me were able to do like full dashboard. Yeah, that's kind of like this is where you can understand where the Pinot sits now, right? So it sits everywhere, like data lands here, and it is capable enough for querying this stuff and to expose this to outside. And even without writing code, you will be able to build a dashboard using something like Superset or Streamlit. I have another demo that uses the Python framework or Streamlit. That's also like you can build data type of applications.
Which of these requires zookeeping?
Kafka, Pinot.
Is there some kind of like effort to?
Let me ask you a different question. Why people so afraid about Zookeeper? Like, I understand that another piece of infrastructure that you need to maintain, but I understand why Kafka people did this. Basically, it was done because Confluent are running massive amount of Kafka clusters, and they paying a lot of money for extra infrastructure to run Zookeeper.
Yeah,
Yeah.
but also moving parts. The more moving parts, the more
Correct.
you need like to administer them.
Okay, yes, of course. That's true. However, like Kafka has like 2.5 years to re-implement this and have an internal storage for Kafka metadata. There's a lot of things needs to be done on the Pinot side of things in order to say that, Zookeeper is the only one problem that we have. I might sound as a kind of like Stockholm syndrome person who was affected by this. Yes, it is a piece of infrastructure that you need to maintain, but it is what it is. You're paying the price for having the low latency, high concurrency, and super fresh data. That's the part of architecture that we play. Actually, I didn't even mention this, but technically, Zookeeper used this on top of another Apache framework called Apache Helix, which is kind of like a coordination and metadata management, cluster management framework that runs on top of Zookeeper in order to support controller and metadata management. So answer is use managed service. If it's difficult for you to maintain, I know people who willingly provide you.
I just mentioned this hypothetically. Is it possible, like for example, like to combine the usage of like Zookeeper for all these products?
I would not recommend to do this. Okay, unfortunately.
So for each of these products,
Different products will be using Zookeeper in a different way. I've seen people ask you the same question when they're talking about Kafka. They say, for example, we use Zookeeper in Hadoop. Can we use Zookeeper, same as Zookeeper or Kafka? Yes, you can, but like, why? Just you're trying to save like few servers, because you end up in a mess when Zookeeper will fail, or you decide to upgrade this for Hadoop, and it will be incompatible with, for some reason, I don't know. Like Zookeeper will be pretty stable and pretty kind of like there's no super long upgrade or like very often upgrades of Zookeeper version. So yeah, I don't have an answer for your question. It's just like it depends. I would not recommend.
So for example, if I to deploy like Flink, Pinot, and Kafka, I will need like 9 Zookeeper.
Yeah. So yes, you with Kafka, you don't have to use Zookeeper anymore. Why? My computer died. Take take a pic of your slide because my computer died because of the power. But I was very on time in order to finish presentation. Yes, like the finish in time. I didn't have another link. We just released the free free trial. It's not even trial. It's kind of like a free forever tier. It has a limitation on 100 gigabytes of storage and 500,000 queries per day or something like that. But it is very good place to start playing around with Pinot without speeding up your infrastructure. I did the demo where I took a trial from Confluent Cloud. I used their connector that just generates some data in Kafka topic. I connected my Pinot cluster, and I used a trial from Superset. It's called Preset. They also have a managed service, and I built this like a serverless dashboard without anything running, and everything was kind of like free-ish or like very small fee. Yeah, so if you see that Zookeeper is a problem, there's managed service that can solve this type of problem.
But do you need in general configuration tool? I mean, if you understand how it works, this is maybe not needed complexity in that one.
So usually it's kind of like in the mode where you set up and it just works, because like I said, this framework that comes with the Pinot controller will maintain all this metadata. So you need to just give the connection to the device, and this controller will be responsible for handling. So Pinot has this feature called deep storage, where segments can be sent as a kind of like this is a backup to some sort of S3 compatible storage. And in case of you restart the cluster and some of the segments were corrupted for the local storage, they can pull this from the deep storage. But unfortunately, the deep storage is only for Pinot data, and it doesn't do backup of Zookeeper data. So this is one of the places where we need to have some sort of like knowledge how we can back up and restore Zookeeper metadata. That's probably in case of upgrades, in case of recovery,
Well, my point is, if configuration tool is too complex, maybe better to not use it, to make something custom for this.
I think that's one of the decisions was made for when the Pinot was created initially. Instead of building some sort of like custom metadata store, use something that is already available. So that's why Zookeeper was great choice, because of the high kind of consistency guarantees that Zookeeper has on this one. Same decision was made for Kafka, and years after, they decide to, okay, we will build this. But also, your place Zookeeper, you still will have one of the brokers of Kafka nodes will be responsible as a controller. Only difference is that it's not called Zookeeper anymore. But also there's like if you have tens of or hundreds of thousands of partitions, initial metadata load will be faster with the craft both versus people.
Maybe we can stop recording.
Yes.
And because you already have no battery.
Yeah.
Discussion can be more informal.
Yeah.
Great presentation.
The way how I like to finish my presentations, like again, it would be a callback to some of my hobbies. Movies. How many have seen Back to the Future? At the end of the Back to the Future 1, Marty McFly said the phrase, "You might not understand this yet, but your kid's gonna love it." So when he was playing the Johnny B. Good on the discotheque or whatever, same thing here. That's where kind of like data intensive applications are going to, with the massive scale, you need to come up with use cases or solutions to solve this kind of use cases where you need to have very fresh data queried in a real time. And it's pretty cool. Some other vendors, they're going to the same directions differently. There is also a thing called Apache Iceberg, which is a tabular format for this data. Yeah. So what, in order to, again, to turn the data into something that would be used as an analytical query, so the Confluent, what they did, they in their cloud, they actually implemented the storage layer that can represent data that's stored inside the Kafka in a format of Apache Iceberg. But this is like a fully like a vendor solution. It's their solution to turn stream into table and vice versa. If the table would be changing, these changes would be.
You're talking Snowflake is using Iceberg.
It's just a format. It's an open source format. There's a lot of like, I guess right now.
Now Microsoft Fabric also starting to support.
There's, I think, three formats that everyone is using. It's an Iceberg, it's a Delta from the Databricks, and the Houdini. I know that there's another format is someone is building. It's called Apache Xtable. That will arguably will finish the wars of the tabular formats. But for now, that's the world. Shitty world because there's a lot of things going on, and definitely not. If you not like to learn new things every other year, it's definitely not fun place, because like in a data world and there's always something new happening. There's no solutions. There's only trade-offs, unfortunately. Or fortunately, I don't know. Like, you know, when you're in consultancy business, there's always opportunity. But from opportunity also, it's another word for saying that was true. But you know, instead of focusing on negative, we're focused on positive. We're gonna use opportunity. So that's how I like to think about this, and how I like to think about all this things going on.
I think we're still live because
Because of this thing.
yeah, we
I don't know, just